Hey guys, in today's video we're going to focus on two unwanted cutter movements known as cutter swing and cutter roll. I'm Tom.
And I'm Deanna. Let's get started.
Let's kick things off by breaking down cutter roll, what it is, how it happens, and how your Hurst hydraulic cutters help you catch it. Cutter roll is basically the tool twisting on its axis as the blades start to bite into material. Instead of drawing straight into the cut, the cutters begin to rotate, which means the blades aren't loading evenly. You'll usually feel the tool start to shift or drift, and that's your sign that the blades aren't grabbing the material the way they're designed to. The good news is your Hurst cutters give you a built-in early warning system. As soon as the tool enters second stage pressure, the computer automatically records the cutter's starting position. From there, the tool monitors its own movement. If it detects the cutter beginning to roll off that 0 point, the power button LED changes from blue to red. That red light is your warning that roll is beginning, so you can correct it. Cutter roll usually occurs when we're tip-loading the blades on tougher materials like high-strength steel, plate steel, or thicker dimensional metal. These are puncture-style cuts, which are different from a full hook cut where the blades wrap around the material. If roll continues unchecked, the blades can separate or even fail. So, the technician must recognize these situations and take steps to minimize the unwanted roll. Door pins are a perfect example. If we cut too early, before the spreader opens enough space, we end up tip-loading the cutter on part of the pin instead of capturing all of it. That causes blade separation and can lead to failure. Proper blade placement starts with proper access. When cutting door pins, make sure you have a clear line of sight to the entire pin. This lets you make a proper hook cut. It's the spreader technician's job to create enough room around the pin assembly before anyone begins cutting. B-pillars made of high-strength steel can also create cutter roll. The cutter needs to fully wrap the post. If the blades only catch the edge, they can tip-load and produce roll. To fix this, move the cutter slightly higher on the pillar or flatten the weld seam to reduce the dimension across the post so the cutter can hook around the full width of the post. Hinges are one of the most common areas where cutter roll shows up, so placement is everything. Hinges are built from thick, high-strength steel and have multiple layers and reinforcement points. If the cutter only catches part of the hinge, like a bracket edge or the thickest portion, you'll end up tip-loading the blades instantly. When that happens, the cutter won't draw forward into the cut the way it's designed to. Instead, it starts twisting on its axis, and that's when your roll indicator light will kick on. The goal is to get the cutter fully wrapped around the hinge assembly so both blades load evenly and the tool naturally pulls straight into the cut. This is where good teamwork with the spreader technician makes all the difference. The spreader needs to open enough space behind and around the hinge so the cutter tech can get full visibility and complete blade seating. If there isn't enough room, you're forced into a poor angle or a partial bite on the hinge, which almost always leads to roll. Before you commit to the cut, make sure the hinge is fully exposed. The cutter fits comfortably around the whole assembly, and you're not guessing at your placement. When the alignment is right, hinge cuts become cleaner, faster, and far safer for both the operator and the tool. Hinge pins can also trigger roll if we don't identify their location. You always want both blades on the same side of the hinge pin, either both above or both below. Never set the blades so the pin is between them. That will force the blades apart and start roll immediately. Now let's look at cutter swing. It's different from roll, but just as important. Cutter swing can still lead to tool damage or even injury if we're not prepared for it. Cutter swing typically shows up in two scenarios. The first is when each blade meets a different type of material, like during a lower A-pillar relief cut, where the inside of the blade bites into carpet or plastic, while the outside blade hits high-strength steel. Since only one blade is really moving, the cutter tail naturally swings toward that side. The second scenario happens when the blades don't engage the material at the same time or with the same amount of force. If one blade starts cutting first, the tool is pulled in that direction. When both blades contact and move through the material evenly, cutter swing is greatly reduced or eliminated. Either scenario can be prevented by widening the wire loom hole or other access point in the vehicle's lower A-pillar between the hinges. The cutter blade can be inserted once the hole is large enough to accommodate the blade tip. This should eliminate the unequal forces between the blades, allowing them to move through the material simultaneously. Cutter swing is also common when cutting hinges because they're wide and flat. The tool will naturally swing along the hinge's long dimension, sometimes pushing the cutter up vertically or driving the tail downward. Swing isn't a big issue unless something, like the ground or body panels, are blocking the cutter's movement. As an example, we must ensure that we don't load the tail of the tool on the ground if downward swing is encountered on the lower hinge. To control swing on hinges, approach with the cutter parallel to the floor pan. Close the blades until they touch the hinge, then pause. See which way the tool wants to swing. If it swings upward, lower your angle. If it swings downward, raise it. Adjust until the tool stays level. Every hinge has a sweet spot where the cutter stays neutral. Find that, then commit to the cut.
With a few simple techniques, you can identify and prevent most cutter roll and swing situations.
Thank you for watching. Follow Hurst for more.